Wilcoxon wrong sum test. What is Wilcoxon wrong sum test? It is a non-parametric test and is used to compare if there is a significant difference between two independent groups. This is the counterpart of the t-test under the parametric test. Generally used when normality assumption for the sample is not hold and sample size is small. Non-parametric statistical hypothesis test for assessing whether one of two samples of independent observations tends to have larger values than the other, like what you have seen in the diagram. Steps. Select a random sample from each of the populations. Let n sub 1 and n sub 2 be the number of observations in the smaller and larger sample, respectively. Arrange the combined n sub 1 plus n sub 2 observations in ascending order and substitute a rank of 1, 2 to the n sub 1 plus n sub 2 observations. In the case of ties, we assign the conflicting observations with their mean ranks. W1, sum of the ranks corresponding to n sub 1 observations. W2, sum of the ranks corresponding to n sub 2 observations. Formula: U sub 1 is equal to W1 minus n sub 1 times n sub 1 plus 1 divided by 2. U sub 2 is equal to W2 minus n sub 2 times n sub 2 plus 1 divided where U sub 1, that is a Wilcoxon wrong sum test. W1, sum of ranks of group 1. N1, sample size of group 1. U2, Wilcoxon wrong sum test. W2, sum of ranks of group 2. N2, sample size. Our decision is based on the value of the test statistic U, the random variable for U. For one tail test, U1 or U2. For two tail tests, U is equal to the minimum U1, U2. And there's the table. Null hypothesis will be rejected whenever the appropriate statistic U1, U2, or U assumes a value less than or equal to the desired critical value. Test statistic is less than or equal to critical. Example: of the 18 selected patients with advanced stage of leukemia, 10 were treated with a new serum and 8 were not. The survival time in years was reckoned from the time the experiment was conducted. Using the Wilcoxon wrong sum test at 0.05 level of significance to test whether the serum is effective, consider the following data. Treatment 2.9, 3.1, 5.3, 4.2, 4.5, 3.9, 2.0, 3.7, 4.1, 4.0. No treatment 1.9, 0.5, 0.9, 2.2, 3.1, 2.0, 1.7. Solving with a stepwise method. Problem: is the new serum effective in treating leukemia? Null hypothesis: the new serum is not effective. Alternative hypothesis: the new serum is effective. Level of significance at 0.05, degrees of freedom, N1 is 10 and N sub 2 is 8, and the tabulated value at 0.05 level of significance is 17. Statistics: U-test, Wilcoxon wrong sum test. Computation: arrange the data of both groups from the lowest to the highest value and rank them. The sum of ranks with treatment will be W1. Likewise, the sum of ranks without treatment will be. So here is the table and here is the ranking. So the sum for with treatment is 130 and the sum of rank for with no treatment is. So we combine the ranking for the two groups and here is the result. Now is the time for computation. So we're going to substitute W1, that is 130, minus N sub 1 is 10. N sub 1 is 10 plus 1 divided by 2. So the U sub 1 is 75 and the U sub 2 is 5. Decision rule: select a smaller value from U1 and U2. If the U computed value is lesser than or equal to the tabulator value, reject the null hypothesis. Conclusion: since the U2 computed value of 5 is lesser than the U tabular value of 17 at 0.05 level of significance with N1 10 and N2 8 degrees of freedom, the null hypothesis is rejected in favor of the research hypothesis that a new serum is effective, implying that patients treated with the new serum live longer when compared with the patients who were not treated with the serum. So thank you for listening and watching.